question is: a DevOps engineer is launching a new application that will be deployed on infrastructure using Amazon Route 53, an application load balancer, auto-scaling, and Amazon DynamoDB. One of the key requirements of this launch is that the application must be able to scale to meet a load increase. During periods of low usage, the infrastructure components must scale down to optimize cost. What steps can the DevOps engineer take to meet the requirements? Choose 2. A. Use AWS Trusted Advisor to submit limit increase requests for the Amazon EC2 instances that will be used by the infrastructure. B. Determine which Amazon EC2 instance limits need to be raised by leveraging AWS Trusted Advisor, and submit a request to AWS support to increase those limits. C. Enable auto-scaling for the DynamoDB tables that are used by the application. D. Configure the application load balancer to automatically adjust the target group based on the current load. E. Create an Amazon CloudWatch events scheduled rule that runs every 5 minutes to track the current use of the auto-scaling group. If usage has changed, trigger a scale-up event to adjust the capacity. Do the same for DynamoDB read and write capacities. Correct answer is C and D. Next question is: a company hosts parts of a Python-based application using AWS Elastic Beanstalk. An Elastic Beanstalk CLI is being used to create and update the environments. The operations team detected an increase in requests in one of the Elastic Beanstalk environments that caused downtime overnight. The team noted that the policy used for AWS auto-scaling is network out. Based on load testing metrics, the team determined that the application needs to scale CPU utilization to improve the resilience of the environments. The team wants to implement this across all environments automatically. Following AWS recommendations, how should this automation be implemented? A. Using EB extensions, place a command within the container_commands key to perform an API call to modify the scaling metric to CPU utilization for the auto-scaling configuration. Use leader_only to execute this command in only the first instance launched within the environment. B. Using EB extensions, create a custom resource that modifies the AutoScaling Scale-up policy and AutoScaling Scale-down policy resources to use CPU utilization as a metric to scale for the auto-scaling group. C. Using EB extensions, configure the option setting measure name to CPU utilization within the AWS auto-scaling trigger namespace. D. Using EB extensions, place a script within the files key and place it in /op/elasticbeanstalk/ to perform an API call to modify the scaling metric to CPU utilization for the hooks/up deploy/pre. Auto-scaling configuration. Use leader_only to place this script in only the first instance launched within the environment. Correct answer is C. Next question is: a DevOps team needs to query information in application logs that are generated by an application running multiple Amazon EC2 instances deployed with AWS Elastic Beanstalk. Instance log streaming to Amazon CloudWatch logs was enabled on Elastic Beanstalk. Which approach would be the most cost-efficient? A. Use a CloudWatch logs subscription to trigger an AWS Lambda function to send the log data to an Amazon Kinesis data firehose stream that has an Amazon S3 bucket destination. Use Amazon Athena to query the log data from the bucket. B. B. Use a CloudWatch Logs subscription to trigger an AWS Lambda function to send the log data to an Amazon Kinesis data Firehose stream that has an Amazon S3 bucket destination. Use a new Amazon Redshift cluster and Amazon Redshift Spectrum to query the log data from the bucket. C. Use a CloudWatch Logs subscription to send the log data to an Amazon Kinesis data Firehose stream that has an Amazon S3 bucket destination. Use Amazon Athena to query the log data from the bucket. D. Use a CloudWatch Logs subscription to send the log data to an Amazon Kinesis data Firehose stream that has an Amazon S3 bucket destination. Use a new Amazon Redshift cluster and Amazon Redshift Spectrum to query the log data from the bucket. Correct answer is C.